Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for three-sum problem where the input array is not sorted. Let's look at the problem description. We are given an array nums and we have to return all the triplets such that their indexes are not same and the sum of their values should be 0. And the one condition is the solution set must not contain the duplicate triplets. Okay. So let's take a look at this example 1. So we have a nums array -1 0 1 2 -1 -4, and in this -1 0 1 add up to 0, so we have that here, and -1 2 -1, so we have that here. So when we process, we may end up having 2 -1 -1 -1 2 -1. So those kind of duplicates should not be returned as output. Only one unique triplet should be returned. There are two approaches to solve this problem. Approach 1 is first sort the array and convert the three-sum problem into multiple two-sum problems, and then solve each two-sum problem using two-pointer approach. So in this approach, the time complexity would be around order of n squared, and the space complexity is order of 1 because we do not allocate any space. For approach 2, we will be solving this problem without sorting the input array. So in order to detect the duplicate solution and then the occurrence of the frequency of each element, we need a hash table. So for that we need to allocate space, and then we convert the three-sum problem into a two-sum problem and solve the two-sum problem, each two-sum problems using the hash table lookup. And here also the time complexity is order of n square, space complexity is order of n because we allocate space hash table. Let's quickly take a look how the approach 1 works with this input. So we are given an input array and we sort it, and that becomes -4 -1 -1 0 1 and 2, and so we divide this problem into three-sum problem into n-2 two-sum problem. So that's why we iterate up to n-2 times. For each iteration, we process the elements which are starting from the three-sum left plus 1 and till the end of an array, and try to find the numbers, two numbers which adds to minus of the previous number which is pointed by the three-sum left. So in this case we have -4, and we try to find any two numbers which adds to 4. In this case it's not, so the first iterations doesn't give anything. In the second iteration, the three-sum left will advanced to -1, and the remaining array will be looked up for any two numbers which adds to 1. So in this case, sorry, here it is 1, and we will look up. So in the next iteration we will take this number out, and in the remaining numbers we look for any two numbers which adds up to 1, so adds up to -1. So in this case -1 and 0, when we add it up, -1 plus 1 0, so that's why we see this. Let's look at the flow chart. This is the flowchart for the threesome problem. So for this procedure, the input is the numbers array and the target value 0. So first we initialize the count to the length of an array, and then output list will be empty, and then we start from the beginning of the array. So I will be set to 0. Then we will have to sort the array in non-decreasing order. Once that is done, we will iterate over this array count minus 2 number of times. So that's what this for loop is doing. So we check if I is non-zero, then we check whether that number is already processed in the previous iteration. If so, we simply skip that number. Otherwise, we compute the target value for the twosome problem. Basically, the current number will be subtracted from the 0, and that will be set as a target num for the twosome procedure. So the twosome procedure will be called with I plus 1 to count minus 1 number of elements in the numbers array. And when that procedure returns, we check whether the list returned by that is empty, then we will continue. If it is not empty, then we add the current number of numbers of I to each element in that out list. So we add the numbers of I to each element in that array so that we form a triplets, and then we add the twosome out list to the output list. Then we'll keep continuing for the next iteration. So once we process entire loop, we will come out and return the output list. So let's look at the twosome procedure. This is little different compared to my previous video, where the duplicates are not allowed in the input array, but here the duplicates are allowed. So we will have to make some slight modification for the two-pointer approach. So this is a twosome problems flowchart, and here the input will be the numbers array and the starting and ending positions within that array and the target value. So we initialize the twosome out list, and then we loop through that array until so this loop will run until the left and right pointer meets. We compute the sum of the elements pointed by the left and right pointer. If the sum is greater, we decrement the right pointer. If the sum is lesser, we increment the left pointer. If the sum is equal to the target value, then we create a list of elements pointed by the left and right pointer, and then add that list to the twosome out list. So basically the twosome out list is a list which has two elements in it. And then what we do, we increment the left pointer and decrement the right pointer so that we can find the next pair which matches the target value in the next iteration. And then if we see the duplicate numbers, we skip them, and then we continue processing the next unique number. And finally, once the left and right pointer meets, then we come out and return the twosome out list. Let's move on to coding. First, I initialize the threesome target value to 0 and count to the number of elements in the input array and the output list. Next, I sort the input array. Next, I iterate over first count minus 2 number of elements in the input array. Then I check whether that number is a duplicate or not. If it is a duplicate, then I skip that number. Next, I initialize the two-sum target value by subtracting the nums of I from the three-sum target, and then I will call the two-sum function with a range I plus 1 to count minus 1 with the two-sum target value. If the list returned by the two-sum function is not empty, then I will go over all the elements in that list and add the nums of I to each element so that we form the triplets. Once that is done, then the final list will be added to the solution output list. Next, I am going to write the two-sum function. First, initialize the out list. This for loop runs until the left and right pointer meets. First, I am computing the sum of the elements pointed by left and right pointer, and then checking whether that sum is greater than the target. If so, decrement the right pointer, else increment the left pointer, else we found the match. Once a match is found, we create a new list with the two numbers pointed by left and right pointer, and then we add that list to the out list. Then we increment the left pointer, decrement the right pointer, and then we have to skip the duplicate numbers from both ends. At the end we return the out list back to the threesome function. Next I'm going to run the test cases. It's accepted. That's good. Next I'm going to submit this program. Okay, cool, it's accepted. Let's do the code walkthrough with sample input. We are given this input array and the target value is 0. So for this input array the expected output is -2, -1, 0, 1, -1. Okay, so first thing what we do is sort this array. So the outer loop runs up to count -2 elements. So in this code the I is the threesome left and the threesome right is equal to the count -2. So basically we divide this into count -2 number of twosome problems. Okay, so that's what the outer loop runs, and so 3 target sum value is 0, and in this the target twosome value is 1. So basically 0 minus -1, so we get 1. We call the twosome function with I plus 1 as the starting pointer and count -1 as the end pointer, and then the twosome target. So inside the twosome function this loop will run until the left and right pointer meets. So then we add those two values pointed by left and right, -1 plus 4, which is comes to 3, which is not equal to the target twosome. So we decrement the right pointer, which points to number 2. So now we add these two numbers in this iteration, which adds to sum 1, which is equal to the 2 target sum. So what we do, we add an element which is in turn a list, contains the -1 and 2, and put in this. And in the next iteration, so after finding the match, we increment the left pointer, decrement the right pointer, both. Now it points to 0 and 1. So when we add these two, that sums to 1, which is equal to the target twosome target. So then what we do, we create a list which contain these two elements and add it to the out list, and we return the out list. So once that out list is received, here so we add the nums of I in this case, which is a -1, add to the each two tuple present in the out list returned by the twosome function, and finally we ended up getting -1 2 -1 0 1 -1. So this is the output the threesome function finally returns. Next let's do the time and space complexity analysis. I'm going to use this input for the analysis, and let's see the time complexity for this. So as per this code, first thing what we do is the sorting. So time complexity for that sorting algorithm in Golang is n log n, and the threesome function has a for loop which will run count minus 2 times. So in this case 6 minus 2, 4 times this loop will run. And let's see how many times two-sum code runs. So the two-sum function has one for loop which runs in the worst case right minus left plus 1 times. Okay, so for this input case, this first iteration run 5 times for this set of entries. Second iteration for 4 elements. Third 3 and fourth 1. So totally 5 plus 4 plus 3 plus 2 times this this particular piece of code will execute. And if we add that up, it will be, if we generalize that, it will be like on iteration 0 it will run n minus 1 times, iteration 1 it will run on n minus 2 times, iteration 2 n minus 3. So if we add all of them, it will be like 1 plus 2 plus 3 up to n minus 1 minus 1. So it's like it's an arithmetic series. So the sum of the first n natural numbers will be n into n plus 1 by 2. So in this case we go up to n minus 1. So I substitute n minus 1. So we get n into n minus 1 divided by 2, which is approximately order of n square. So the overall time complexity is so for sorting n log n plus the two-sum problem solving n square. So the overall complexity is, we take the dominant term, so which is order of n square. With respect to the space complexity, we do not allocate any additional space with respect to the input size. The space complexity for this algorithm is order of 1. Let's look at the code for approach 2, where the sorting is not done on the input. Okay, let me share the code for approach 2. So let me quickly go over the code. So in this case, we need a to map hash table. One is the frequency map, which contains the frequency of each numbers in the input, and the solution map contains for each unique number in the input list what are all the possible combinations that forms the triplets which sums up to 0. Okay, so and then the output list. First I am initializing the frequency map and the solution map. So whenever I see the element first time, I initialize the frequency to 1. Whenever that element already exists in that hash map, I increment the frequency each time I see. I compute the target value for the two-sum, and then I pass the frequency map and solution map and the current index of the number which we are processing, the first number, and then the target value. So once this two-sum function returns, we add that list to the out list and return back. Let's look at the two-sum implementation. So here, once we first we initialize the first num, and then we decrement the frequency of the first num because the first parameter is the first num. So the rest of the array should have one less number of the first num. So we decrement that, and then when we return back from this function, we have to increment it so that for a different first number, this frequency should be the original one. So we have to revert it. to its original state. So that's why I defer that function. Before this function is returned, that will be incremented automatically. And then I will go over the nums array, and whenever I see the index, which is the index of the first num, we will skip that. Then I will compute the third num, which is the two sums target. Okay. Then once that two sums target value is derived, I check whether the second num or third num exist in the solution map. So I check whether that exists. If both the second num and third nums are existing in the solution set, then it is a we do not want to have the duplicate solution set, so we continuing skipping that iteration. And if the frequency map has the third num in it, that means we have that target value for the two sum. So we get the count because we want to make sure the enough number of the third num exist. Then I check 4 cases. Only then I add that 3 numbers to the list. So those conditions are, so the first condition is all the 3 numbers are equal. In that case, count, the third number's count should be greater than 1. And the second number is equal to the third num, and it's not matching the first num. The third condition is first num is matching the third num, and second num is not matching the third num. And the fourth condition is, and first num and third nums are not matching. So in those conditions, either of those conditions met, then I add the 3 numbers to the list. And once that is done, I mark that particular number as part of the solution. So for each, the solution map, for each first number there will be an entry which contains a map which indicates whether this number is present or not. So for the first num, second num and third num are part of that solution, so I mark them as true. For the second num, the duplicate case, first num and third nums are present, so I mark it as true. For the third num, first num and second num are the second and third parameters, so I mark them as true. So once that is done, all these operations done, at the end I mark we computed the solution for first num. And then finally I return the out list back to the 3 sum. A 3 sum in turn add that list to the out list. Okay, let me quickly run this program. Okay, all the tests are passing. Now I am going to submit. So it took 1.3 seconds, which is way high compared to the solution which do the sorting on the input. Thanks for watching this video. Have a great day.